Okay, our sixth problem is Luke Skywalker and Leia Organa, Princess Leia and Luke, escaping from the Death Star, and they got to swing across this pit here using this cable that Luke was carrying, and they go all the while stormtroopers are shooting at them, and they make it across. So they go at a speed 5 meters per second. They swing from this cable, which is 5 meters long. And what is the tension in the cable when they're at the lowest point of their swing? So, what happens here, and this is the wreckage of the last problem. Pardon me, let's just dust that away. Alright, so, what happens here is, right, don't cover the thing. Okay, there we go. So, what happens here is they are going through a circle, okay, with a little black spot, as Luke and Leia were just going to say. A circle with a radius of 5 meters, r equals that. They've got a velocity of, or a speed of v equals 5 meters per second. So what is their acceleration here? First of all, it goes up right towards the center of the circle, as acceleration in circular motion always does. A equals v squared over r, which is going to equal, 5 squared over 5. What's 5 squared over 5? Wait, don't tell me, I'll get it. That's right, acceleration is 5 meters per second squared. That is just too easy. Okay, so now let's draw a free body diagram, or let's see what's happening with Luke and Leia. They've got some mass there. They're hanging from a cable, and they have got there's cable tension pulling them up, right? And then there's mg there, and we know they are accelerating upwards. This acceleration A. So, too easy. FBD. Boo. And there's our X and Y. And so, X, Y. There's the tension. There's mg. Sum of forces in the Y direction equals mass times acceleration, which is positive Y, of course. So, T minus mg equals ma, which means T equals mg plus ma, or m times g plus a. Okay, the mass, total mass of Luke and Leia was 120 kilograms. I'm going to say g equals 10 meters per second squared, and of course here we found a equals 5 meters per second squared. So we take those, plug them into this, and what we get, I'm going to do it in blue, is tension equals 120, not 28, what am I doing? 120 times 10 plus 5. 10 plus 5 is 15, of course. 120 times 15 turns out to be 1,800 newtons, or like 17 something something. If you were, say like 1776, I think, if you were using 9.8 for G. So there we go. That is that probably the fastest problem I've solved. So let's just go on ahead and take a look then at problem 7, the very, very last one. So in this system, I think we get this. We got this single cable threading all the way through these pulleys and stopping at point P. Right, and if the pulleys have negligible mass, what is the magnitude and direction of the acceleration of these two blocks? So what this is basically is, this is our introduction to mechanical advantage and machines and all that. So what we have here is this pulley, which is right up here, and then this pulley, which is like that. So here is our, I'm going to call this M2, I'm going to call this one M1. Cable goes like that. So the key things to recognize here are, first of all, the forces, how those work. Each one has weight, right? Now, this cable is being pulled up by the tension, or this block is being pulled up by the tension in this cable. This block here is being pulled up by the tension in both cables, actually. So we're taking a free body diagram of this block plus the pulley, and there are two cables pulling up on it. Whoops, wait a minute. I drew that one wrong. But okay, there's cable, other cable. There we go. So there we go. Tension, tension, tension. Bloop, bloop. And then the other thing to recognize is how these things are accelerating. So let's say M2 accelerates upward. Okay. if it moves upward, let's just say if M2 moves upward a distance, say delta x, so M2 moves upward a distance delta x, then what happens? How far does M1 move? Well, if M2 moves upward, this section of cable shortens delta x by delta x. This section of cable shortens by delta x as well. So the total shortening of cable when M2 goes up is 2 delta x, which means, well, where does that cable go? It all goes over here, which means if this guy moves up by delta x, then a 2 delta x length of cable suddenly appears here and gets used to push M1 down. So if he does that, then M1 goes down 2 delta x. Makes sense? So M2 goes up some distance, M2 goes down twice as far, which means if their velocities then, so if M2 is going up at some speed, M2 is going down at twice that speed, and then again take another level up. If M2 goes up at some acceleration, or accelerates at some acceleration up, then M1 accelerates down at twice that. So that's the thing to understand about pulleys and mechanical advantage and all, is that if you get more force by stacking up tensions from multiple cables, well, that means this thing isn't going to go as far as the other one. And that'll be important when we get to work later on. Work is force times distance, so you can't actually get more work, because if you wrap the cable up a bunch of times, get more force out of it, you're getting less distance. All right, anyway. So let's do a free body diagram for M1 right here, and that is going to look like, so I'm going to just do positive y upward for both of these. Okay, so there's our y up, and what it looks like here for M1 is you've got tension, and then you've got M1G. Okay, so sum of forces in the y direction on M1 is equal to, well, we're saying if A, if we're defining this A here as our acceleration, so the actual acceleration of M1 is going to be negative 2A, because it's going to be accelerating 2A downward. So equals M1 times negative 2A. Okay, so these forces are tension, and then the downward force of gravity equals negative 2M1A. So I'm just going to solve for tension here. Tension equals M1 times G minus 2A. Okay, now let's do the FBD for M mass 2, and that is going to look like, okay, so there's our Y, and that is going to look like that. There's going to be a T, and then I'm going to make this wide so I can do another T. Biggest dot ever. Alright, and there's M2G, and I'm going to do some forces in Y, and that's going to equal, and this just has acceleration A upwards, which matches that, so that, we can do just M2A. Sum of forces in Y is 2T minus M2G equals M2A. So now we can say, I guess, I don't know, how do you want to do this? We can say 2T equals M2 times A minus G, or sorry, A plus G, because we bring this over, it becomes positive. So that's all, hunky-dory. So now let's just take, I guess the thing to do is take, what do I want to do? Take this equation here and substitute in this T here into that. So what we're going to get out of that, let's come over here, and we're going to say 2 M1 G minus 2A equals M2 A plus G. Okay, so let's see, let's just expand it out and say let's see, 2 M1G minus 4 M1A equals M2A plus M2G. And scrolling down one more, so we have this equation here. That's not an answer, I'm just boxing it so I know what's going where. And we're going over there and do oh geez, yeah, so let's bring all the A's. So let's do negative 4m1 minus m2 times A equals negative 2m1 plus m2 times G. Is that right? So this goes over, this comes over, it's all good. Okay, so let's do A equals, and I'm just going to positive, 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 negative. Okay, so now A equals 2m1 minus m2 over 4m1 plus m2, okay, times G. All right, well, the moment of truth now. Let's see what this will be for, let's see, so for, well, I'm not going to do it there, but let's say down here, let's go green. Okay, so for M1 was our 6 kilogram weight, M2 is 10 kilograms, and then, yeah, that was all we had, right? So, and of course, G equals 10 meters per second squared. So, let's see, A equals, let's see, 12 minus 10, so 2 times 6, 12, right? 2 over 4 times M1 is 24, 34, 2 over 34 times G. Wow. Well, that is going to be small. Actually, I'm sorry, and G was 10, so actually this equals 20 over 34. So A equals, let's see, 20 divided by 34 equals 0.59 apparently meters per second. So A equals 0.59 meters per second squared. Okay, so let's boxy up that one, and that's A for, if I recall right, that was acceleration of m2. We said that was A, so, and that is going to E. So let's just say m2 goes acceleration of, A m2, I guess, equals 0.59 meters per second squared up, right? And then for m1, acceleration of m1 is twice this, so what does it mean, like 1.18, call it, meters per second squared down. So I think that looks good. So I just want to verify this. So we said tension, let's see, what's a good tension thing? Tension is m1 times G minus 2A. So tension is m1 times G minus 2A, and we said A was 0.59, so 1.18 is 2A. So if G is 10, 6 times 10 minus 1.18, like 8.82, equals, this is at 48, let's see, 6 times 2, 2, 1, and then 6, 8, 9, 4, and then 5, 2.92. So about 53 newtons was the tension in the cable. So let's just come up and take a fast look at this and say, okay, look, so if the tension was 53 newtons, then real fast on M1, the weight of M1 was 6 times 10 was 60, and this was 53 newtons, so that was a net 7 newtons down, and 7 newtons divided by 6 kilograms is going to be around 1.18 meters per second squared down. I'll buy that. And then on M2, let's see, we had 2 of these tensions. So we had 106 newtons going up, and then going down we had 100 newtons, which means that we had roughly 6 newtons up was our net, and divide that by 6 newtons divided by 10 kilograms equals 0.6 meters per second squared up, and that is also what we had for Mass 2. So let's check out for both. Woo, it's done.